Cool. Welcome. So today we're going to be talking about scripting, which is just a fancy way of saying coding. So I know some of you may not be programmers. You may be thinking, oh my God, this actually is not for me. I'm going to quietly put a zoom in the background and then do something else. Please don't. So if you're a programmer, this actually is for you. It's going to teach you how to use programming language and do the stuff you want to do in Unity. But if you're not a programmer, you can think of it as like when you watch TV, you will see these TV shows about how to smith, how to like make swords and stuff. You know that in real life, you're never actually going to use these skills, but it's fun to watch. So think of today's lecture as that. It's a fun way to learn how programmers work and some of the tricks programmers use. So as I said before, I sent the download link in the chat. And you should be able to download a Unity package. And let me share my screen. All right. Oops. Oh, see my screen now?
Yeah, we can see it.
Nice. All right, I'm going to bring up Unity. So once you have Unity Hub open, you can click New. And let's create an empty object or empty project first. Because I already have one, I'm not going to create it. But once you got here, just create one. And then you should be able to get the empty Unity object. Wait, say some music in the lecture. That would be fun. And once you got here, you can skip new version. Now, so we have a Unity project now. Is everyone ready to go? And as Woody said before, today's lecture is going to be pretty quick. And yeah. So first thing you want to do, you can select 3D. It doesn't really matter at this point because we're going to import packages, but I just chose 3D. And I never remember the menus, but you can just search import packages. To be able to see in assets, import package, and custom package. And once you do that, you should be able to just drag the package you have here and open. All right, import. So make sure everything is selected. It should be selected by default. And once you click input, you should be good to go. All right, you may see an error right here. Let me set my Unity default. All right, so you may see an error. This is because we are using some different version. Just go there and delete the script. You should be good to go. So. All right, once reset. Delete. Yeah, we should have removed that like way after the base code, but simple activator. And after you delete these two bars, you should have a clear console. Yeah, this is a clean console. Usually I just ignore the warnings, but yeah. All right. So we can get started now. I'm gonna open up a sample scene. So this is a super empty Unity scene we have right now. And to get started, let's just create our first script in Unity. So usually we'll create a new folder just to keep things organized. Local scripts. And then we'll just create a new script. So you can right click, create, and C# script. And once you do that, it'll prompt you to enter a name. I'm gonna call it start tester. And once you do that, if you double click the script, it should open up Visual Studio for you. Oh, I already created a start tester. So that's not bad. That's a bad name. I'm just gonna call it Hello World. So this is actually another interesting thing. If you change the name of the script right now, you also need to change the name within the code because Unity requires you to have the same name. Needs to have the same class name as the file's name. I'll show you when it's open up. Or I don't know why it isn't. Oh, it's loading now. All right, here we go. So this is the code we have right now. So don't be afraid when you look at the code. I'm going to explain the code line by line. So as you can see here, first of all, this is has a red line, and this is because I changed the name of the file. So if you change the name of a file, remember you need to also change the name over here. All right, once you do that, the error should go away, and remember to save. And now let's look at the code line by line. So first, we have these three things that says using. Using in Unity or in C# is just importing something.
Right.
So system, sorry, what?
Yeah, sorry, I just was late. Disconnected.
Okay. Yeah, if you're gonna go to, I think I also sent the link in Discord so you can download the
Yeah, I found it, yeah.
a package. Yeah, and while you're just downloading, you can also follow just like a, because today's lecture is going to be, I'm going to show a bunch of different features of Unity. So I am expecting most of the students may not be able to follow along. So if you are unable to follow along, just listen to the lecture and you'll be good to go. And as we were saying, I just created the first script. And the first three lines is just using. So these are the packages written by Unity or by like my people at Microsoft who created C#. And the using is just importing the code they wrote to the scope of your code. You can call stuff that they wrote. So if you don't know what that means, just ignore these lines. This is the same as import in Python. Or yeah, what's the word? I think include in Java or C. And now this is the fun part. Public class hello world model behavior. So you only need to care about this field. This is the name of the class you're creating. Or it needs to be the same name as the file name, as I've just showed you guys. And this equal icon here, this means you're extending your current class from the for the parent class. And if you know other languages, this just means extend. If you don't know what that means, just doesn't really matter at this point, because we are not going to really change this much. At least at the early, when you start using Unity, you're not going to change model behavior. Almost all the classes you created or all the scripts you created is going to be extending from the model behavior. So you can just ignore this part and ignore this part as well. And just remember to change the name if you change the file. If you change the file name, change the class name. And here's the fun part, start and update. Unity is pretty nice. It already tells you what start to do. It says start is called before the first frame update. So what is a frame? So I'm sure you guys know, when you're playing a video game, it's essentially a bunch of images. I'm showing you 60 images per second, and that's why you feel like the characters are animating. But in reality, it's just a bunch of pictures. So that's also how Unity works. Over here, we have start. Start is called before the first frame update. So it's called at the very beginning of the game, and or at the very beginning when this object is spawned. Sorry. So you often use start to initialize stuff. For example, you want this object to be at a certain location when the object is spawned. That's where you put stuff in start. So I'm going to do a very easy thing. I'm going to delete update for now. And I'm just going to do debug.log. I'm going to put hello world. And then remember to add this semicolon in the end to close the whole thing. And once you hit save, then you should be able to create your first program, your first script in Unity. So if I hit play right now, what do you think will happen? Anybody want to take a guess? Well, somebody's asking, what is the line of code? Yeah, just debug.log. You can put anything inside the quotes. So once I hit play, you may notice nothing happened. And that's because we didn't put the script into the game at all. Right now, the script is just sitting here as like one of the independent, just like a file sitting in your folder. It doesn't do anything unless you add it to the game. But how do we actually add the script to the game? We add the script to the game by attaching the script to one of the objects. So let's say I'm going to create something. Any suggestions? Any preferences?
Cube.
Cube. Okay, we have a. I'm going to create a companion cube from Portal if you play that game. But as you can see here on the right side of the screen, we have all these things. All these things are called components. And here, what we're going to do now is going to drag the script to here. You can put it whatever you want, but once you drag it here, the script you wrote become a component to the game object. Somebody asking how to lock a companion cube is not including this section. Wait, actually, this is not supposed to be today's content, but I can also quickly show you how to attach texture to an object once Firefox put it out. But anyway, back here we have hello world, right? So once this script is attached to the game, and when we hit play, what will happen? Well, as one of them pointed out, the line hello world will actually be printed out. But where is it printed? It's printed in the very left bottom lower corner. Like if we click console, you can see the printed line here. All right, so right now we have a cube, a companion cube in the game. We have a script that does something. Now let's start. The start function works, and you may notice the hello world is only printed once when the unselect collapsed right now. But as you guys remember, there's another function called update, right? In update, it's called once per frame. So whatever stuff I put here, this function will be called 60 times or even more per second. So if I save the game right now, save the file right now, and if I come back here, and if I hit play, it's gonna load for a second to compile everything. But if I hit play, it's gonna print out a bunch of hello world. And this is because it is being printed like 60 or 120 times per second. And if you hit this button collapse, what it does is it will collapse all the same messages to a group and then just show you the number of times it is printed. So once I hit resume, you can see this number is increasing like crazy. But if you hit pause, it will just stop. So that's essentially what update does. Update will call whatever you wrote here once per frame. So as you can imagine, we can use say start to set a speed, and we can use update to actually move the object when we want to move it. And I should have downloaded the image before that. Is there a texture for that? Oh, all right, I'm just gonna grab whatever. But this is the fun thing you can do in Unity, which is if you drag something from the internet, and if you just drag it, this is not gonna look good, but if you just drag it here, and then if you just drag it on top of the object, it will automatically apply the texture to the object. But I don't know why it's so dark. It could have something to do with the texture itself. But this is not related to today's content, but it's a fun thing to do. Anyways, yeah. So right now we have a script that prints the stuff, right? This is fun, but actually it's not fun at all. But it doesn't do much. So I'm going to introduce something new. It's called a serialized field. And then I'm going to do something like say serialized field private string, and I'm going to call it print stuff. So let me explain what I just did. You may notice that there are a lot of fields here. For example, the position, the rotation, and the scale. These are the stuff you can edit, right? But what if I want to edit something within my own script in the editor here? So by the way, this whole thing, the whole panel here is called the editor, and this is called the script. So I want to change the values within the script in editor. How do I do that? Well, I use serialized field. What serialized field does is saying, okay, I want to expose this print stuff variable out so that you can just change the value here. For example, if I save the file right now, and if I come back here, you should be able to see another thing pop up. Yep, print stuff. You can see the variable I just named. So if I say change this name to goodbye. No, that's bad. I love 15 122. And then if I save the thing, and if I come back here, so over here in start, if I do the same thing, debug.log, and I put, instead of putting a string, a quotation mark, I just put print stuff. So what do you think will be printed if I play the game now? Any guess? No? No guess? Okay, that's sad. But if I play a game now, oh, I love this song. Yep, I love 15122 will be printed. So that's a very efficient way to change stuff. And this is because, originally I put this line in start, right? But what if I put it in update? And I play the game. So you would expect it to print out a bunch of I love 15122, right? I don't know why it's so slow, but what? I clicked it twice, my bad. So I'm gonna uncollapse it. You can see it's printing a lot of I love 5122. But what if I change the stuff? As you can see here, the stuff that's being printed also changed. If I change this to say a bunch of number, that number will be printed. But if I stop playing the game, it will go back to the original value I set. So in Unity, you can actually change the value over here while the game is playing, which is really cool. So as you can see here, at first it's I love 15122, and then it became the bunch of nonsense. I'm gonna collapse. Yeah, and then it became a bunch of nonsense, and then it become a bunch of numbers. And this is because I'm changing this value while the game is playing. But it's worth noting that if you stop playing the game, whatever value you change when playing the game, once you stop playing it, it will just go back to the original value. But yeah, that's how serialized field works. And now let's look at something more interesting. Right now I just show you how to use string, right? So I'm gonna show you a script we have. What's the name of it? Oh, it's called lots of field testers. So if you search for lots of field testers, you can see this script has a lot of serialized fields. And this is just the way to show you that you can actually make a lot of different types of variables available for anyone to edit. For example, if I drag this script here, so you will see a bunch of these fields. These are coded by us. We can just say, okay, I want a serialized field that is the integer. I want it to be a string. I want it to be a vector 3. And you can just add this stuff here. So yeah, just as you know, you have a lot of freedom over here. You can even drag an entire game object into here, if that's what you're into. And I'm gonna remove that for now. And then let's see. All right. So right now we have a cube, right? But it doesn't do anything, and it's super ugly. But what if we want the cube to actually move? So how do we actually move stuff? First, to move something, we need a velocity, right? We also need a direction to move at. And then we just like move a small distance every single second. And then that's how the object actually moves. So we're gonna apply the same logic here. First, we need a velocity. First we need the speed. And then we need to time that speed to the direction to have velocity. This is middle school physics coming back to me now. So let's say we serialize the thing, we have a variable called speed that anyone can edit over here in the editor, or the developers can edit in the editor. And then I'm gonna delete that for now. And then we also need a direction, right? So I'm gonna say private vector 3, and then the super direction. And it needs to be a new vector 3. So I'm gonna also initialize it here, just do 100. Okay. So only this field will be exposed if I come back here right now. Oof, I don't know why my computer is so slow. Oh, I think it's because Zoom is also sharing and recording. So yeah, so you can see you can add the speed here. Let's give the speed a default value. Let's say like, I don't know, 2. So this will be 2 meters per second. So all the units in Unity are in meters per second. And then we can actually move stuff. So to move stuff, so we can think of it as every single frame, we are moving a little bit. So first we do transform.position. What is transform? Well, transform is slowly. Transform is just the object. You can see here, there's a component called transform. Over here, this is transform. So when I do transform.position, it's just going to give me the x, y, and z value. But I can also set the value to a certain thing. For example, if I set the transform.position to the previous transform.position plus the speed times the direction. So this is just taking the previous position, add the increment, and then set it as a new position. So if I play the game now, what's going to happen? Wait, did I save the file? I don't think I saved the file. Wait, I did save the file. Oh, this is probably because in serialized field, the speed is still 0. Because the stuff you set here is going to override the stuff you set in the script. So if I change this to 2. You can see it moves very quickly to the right. I'm gonna do it again. You just move away very quickly. But that doesn't make sense, right? Why is it moving so quickly? Well, that's because, remember, this is in meters per second, and direction doesn't have like a unit or something. So essentially, we're actually adding meters per second to the position instead of adding meters to the position. So what we need to do here is we actually need to multiply the time, which is time.delta time. So what time.delta time does is it will return the difference between the current frame and the previous frame. It will just give you like a very small like time frame between the very small time difference between the 2 frames. And if you multiply that different time difference to the speed, you will get the actual amount of position that the object should move within the 2 frames. Because remember, update is being called like once per frame. So that will be like 60 times per second. So if we don't have time.delta time here, since this function is called 60 times per second, let's just say that, then this is actually 60 meters per second because you're updating this 60 times per second. So we need to multiply the time.delta time. And once we play a hit now, the object should move much slower and it should move at the correct speed, which is 2 meters per second. All right. Any questions so far? Oop, I see a lot of chat. Okay, so next I'm gonna talk about the give me 1 second. Yeah, next I'm gonna talk about how to access other components in the game. So we're gonna pull up a script called change material tester. So I'm gonna attach that script. I'm gonna disable the script I just wrote. So if you check this box or uncheck the box, it will disable the component that is attached. And then I'm gonna drag the change material tester. So let's look at the code line by line again. First, we have the using. Using is just importing stuff, it doesn't really matter. And then this line is new. It's saying require component type of mesh renderer. So as you can see here, we have a lot of components here. And right now we're going to talk about how you can access another component by changing the values in another component through scripts. So that's why we need to, since our script is depending on the mesh renderer component, we need to require that they actually have the mesh renderer component. So this is what this line is doing. So what will happen if you drag the script to a object that does not have a mesh renderer? Well, if you do that, it will actually automatically add the mesh renderer. Wait, why is it not added? It will actually add the mesh renderer for you automatically, as you can see here. So this is a very nice thing to have, especially if your script is depending on other components. I'm going to delete this. All right, coming back to our cube. And then this line is just declaring a class, and remember to have the class name to be the same as your file name. And then over here, we have a serialized field, which is making this object exposed in the editor so that other developers can edit. But you may notice that this is an interesting type. It's called gradient. So as you can imagine, a gradient is just a color gradient. So if I double click this, I can actually set, say, the one end of the color to a certain thing. What? All right. Any preferences? All right, Woody, what's your favorite color?
Orange.
Orange. There we go. All right, and then pick a random person. Brandon, what's your favorite color?
Blue. Light blue, light blue.
Oh, that's also my favorite color. I like dark blue, but yeah. So you can
light
basically
blue's
set,
better.
yeah, you can set one end of the color to a certain color and then the other end to another color. So let's do, wait, you want light blue, right? So this color. All right. So you have a gradient here. It actually visualized very nicely over here. But coming back to our script, so this is what these two lines is doing, is exposing this variable called gradient for people to edit. And then let's look at these three lines. So this is serialized field, as you have already known, it exposed the cycle length variable for people to edit. And then this is a new line, it's called tooltip. So what it does is it will actually prompt this sentence when you put your mouse over the thing. For example, if I wrote the script and somebody else, maybe an artist or a environment artist, come in and actually edit stuff, then it's important for them to know what each field is doing. So using tooltip, you can actually add this sentence saying length in seconds to cycle through the gradient. Like this little tip for other people to see, so that when they change the value, they know what they are changing. And this is a super nice thing to have if you don't want to be like very irresponsible when coding. All right, and then let's look at this line. It's declaring a private variable called the renderer. All right, so over here in the start, as we have said before, start is being called at the very first frame. Nope, start is being called at the very first frame of the game. So this is also a new function. It's called a gap component. What it does is it will actually, so our script is over here, right? When you say gap component mesh renderer, this Unity engine will actually look up and see, oh, do you have this component? Oh, you do have a mesh renderer. So I'm going to drag this component and store it in this variable that you name renderer. So that's how we're declaring this variable over here. So essentially what gap component does is just grabs the component for you. So you can actually reference it later in the script. And then in update, we're actually updating stuff. So we're actually changing stuff. So this line is just a crazy calculation to get a cosine function. So it doesn't really matter for our purposes. But what this line is doing is saying, hey, the gradient, which is the thing we just set over here, I want you to evaluate this time A. So A is a float, it's a time. It's essentially like a time. So gradient is essentially a function between time and the color. So what this evaluate is doing is taking the time and returning the color. And then what this line is doing is saying, okay, renderer, we just got the renderer, right? The mesh renderer. I want renderer's material. I want that material's color to be the color we just evaluated from the gradient. So essentially, it's grabbing the mesh renderer. I'm getting the material, which is over here, and then you will set the color of this material. So if I play the game right now, oh, I probably should not have attached any material here, but yeah, that's a bad idea. All right, I'm gonna destroy this companion cube. But actually, this is also a good time to show you how to copy component. So I'm gonna create a new companion cube. And then I'm going to copy this component because I don't want to drag a new component to this new cube. Oops. Oh, because I locked it. I don't want to drag the new component to a new cube. That's because I already set this beautiful gradient here, and I would hate it if I lose that. So what I can do is I can do copy component, and then wait, did I chose delete? And then if I do wait, did I chose delete by accident? All right. Oh, I chose remove component. If you do copy components, component as new, nice gradient versus. If I play the game now, wait, it's an error. It says the time parameter is not a valid number. It's because we actually did not set the cycle here. So if I say I want to cycle through the entire gradient in 5 seconds, and let me delete that. You should be from orange to blue. Yeah. And then as we have demonstrated before, if you change this value, if you change it to like a super small value, 1 second, it's gonna cycle through the entire gradient in 1 second. And if I do 10 seconds, it's gonna cycle through very slowly. That's how you grab another component and change its value. You can just use the get component function to grab another component within the same object and then set the value of that object to something else you want it to be. And yeah, so that's pretty much it for the component part. Now let's look at the physics part of the Unity engine. So far we have this cube floating, right? But what if I wanted to do something? So I'm gonna create another cube. I'm gonna make it very flat. So it becomes like a ground for the other cube. And I'm gonna drag the cube up a bit. And I'm gonna rotate it a bit. So if I play the game now, what's gonna happen? Oh, nothing's gonna happen because I didn't change anything. It's just gonna stay like that. Actually, why is the camera so low? Let me drag the camera up a bit. Good. All right, nice. So what if I want the game to have gravity? Well, you need to add something called the rigid body. Rigid body. So you may notice there's something called rigid body 2D. So since we're making a 3D game, you can just use rigid body. But if you're making a 2D game, Unity also have a physics engine for 2D. If that's the case, then you can choose box slider 2D and also rigid body 2D. But right now, just choose rigid body. So if I play the game now, what's going to happen? Well, it's going to fall. So I just spent like the Earth spent thousands, millions of years to create gravity, and I just spent like 2 seconds, and there we have gravity. Nice. So let's look at how this is helpful in a script. So for example, if I want when a cube hits the ground, I want it to like say something. I want to print out the message, for example. How can I do that? Well, I'm gonna create a new script. Where is it? Script, create new script, collider test. It doesn't really matter what you name the script. So I'm gonna drag that script to the object. And another way you can create a script is just by typing the name here and then just click new script. That will also work. Collider test. And if I double click it, all right. So this is actually a function called collision enter. Wait. It's not loading the Unity stuff for some reason, but wait, why is my Visual Studio being weird? All right. Usually you don't have to. Usually you don't need to type all these stuff. You should just give it to you. All right. So what onCollisionEnter does is this function will be called if my object collided with some other object. So for example, if I do debug.log and I actually put name I am hit. And if I save it, I come back here. Wait. Oh, it needs to be collision. Okay, I just spelled the name wrong. It needs to be collision, not collider. Anyways. I hit play. Then as soon as the our box hit the ground, you'll see the message I am hit. So this is essentially what onCollisionEnter does. It just tells you, oh, you entered another object, you collide with another object. But sometimes you don't want it to be an actual object to collide with. Sometimes, for example, if a player arrives at a certain point, you need to save the game, for example, but you want that to be a trigger. And that's what this checkbox is for. So once I hit its trigger, this box essentially will become invisible. It's invisible to the physics engine. So it will now no longer block the box that is falling. So if I play the game now, the box will actually fall through the ground. And this is because the floor cube, the floor over here will just become a trigger area. So the trigger area only sees whether you collided with it or not. It doesn't actually block you or anything. So as you may notice that onCollisionEnter is not going to be code. Instead, another function will be called, it's called onTriggerEnter. Yeah, it's working now. So if I do onTriggerEnter and also I am hit, and if I play the game now, once the object falls through the hit the ground or enters the trigger area, this will also be called. So again, you may want to use trigger when you don't want there to be an actual collision. You just want to see whether the player or the object arrives or not. But you may want to uncheck the trigger box if you want there to be an actual thing to block the player or block the object. So of course, there are some other functions that may be super useful. Let me show it to you. Here. So there's actually a suite of other functions called, for example, we just show you onTriggerEnter, but there's actually a function called onTriggerExit that will be called when the object exits the trigger area. Similarly, there's onCollisionEnter and onCollisionExit. So here's a very nice graph that showcases what it means. For example, we have a cube that is falling, and we have a trigger area and the ground over here. So the trigger area has this its trigger mark checked. Now, when we play the game, when the box first hit the trigger area, then the onTriggerEnter will be called. When the box fall out of the trigger area, the onTriggerExit will be called. And then if the the cube first hit the ground, then onCollisionEnter will be called. And because it doesn't fall through, so the onCollisionExit is not called in this case. But that's essentially what these four pretty important functions does. And this is some of the most basic functions. You're going to use it a lot when you start making your games. So feel free to reach out to us if you get started using these functions. But these are for 3D games. There are also a lot of corresponding functions for 2D games. For example, they have onTriggerExit 2D, onCollisionEnter 2D, and onCollisionEnterExit 2D. So these will be used in 2D games. All right. Now let's look at something else. What if when the cube hits the floor, I want to do something crazy? What if I want to say like the floor to explode or like have a series of events? I want to have people clapping. I want to have a score increase. I want to have a game that says you win. So there's like a sequence of action basically I want the script to do once I hit the ground. And this is why we're introducing the Unity event system. So again, we're going to say serialized field, which again, we are just exposing this variable in the editor. And we're going to do private Unity event. Wait, is this Animal Crossing? And then, but you may notice that it's giving me this red line. And this is because if I want to use the event system, I need to explicitly say Unity engine dot events. And yep, we're good to go. And I'm gonna call this enter. So once, if I save the game now, it's gonna take a second to load. All right, so if I come back here, you can see we have this new field over here that is below the script. So this is essentially a list. So it's a list of actions you want the game to do once they would hit the ground. And let's just say we have like this sphere that represents, I don't know, like a bright light or something. I'm gonna make it bigger, actually much bigger. So I want this sphere to show up as soon as the box hits the floor. So I'm actually gonna turn off the sphere for now. So you can check this box by turning turn stuff off. And then over here, in the event on enter events, I can click the plus button. So I'm adding an event here. I'm adding an action here basically. And then I can actually drag the thing here. So if I drag this object here, then it asks me to select a function. So I'm gonna select the most basic is active. Wait. Game object set active. So I want it to be true. So basically what it will do is it will call this function once this event is being invoked. And as you can see here, I can actually add a series of events if I want to, a series of actions if I want to, if this event is happening. And then come back here. So since the cube is not a trigger anymore, I'm actually gonna do a on collision enter. So on collision enter. And then I'm gonna do on enter invoke. So once you call a dot invoke, Unity will just come to the place where you define the events, which is in the editor over here. Why is it still loading? Yep, you just come here and do this action one by one. So right now, if I play the game, note that the sphere is not here at the beginning of the game. But once it hits the ground, the sphere will just appear. So that's essentially what the event system. You can actually have a super long list of events like you want the engine to go through. And yeah. So afterwards, let's go to our one of the more interesting concepts. Wait, where did I put this? Scripting intro. Read that example. Here we go. All right, and not gonna save this. So imagine you you just learned all the stuff I just taught you, and you become a super qualified game developer. And right now you're working at a AAA studio where your job is to make fences. So you are making like hundreds of fences in Red Dead Redemption 2 or something. Now, say like the producer of a game comes to see your work, and he or she just said, "This fence looks bad. I want you to lower the first bar, the top bar, way down here. Yeah, that looks much better. Now, go and change every single fence." It sounds like a very fun job, right? But actually, that's super frustrating because you don't want to change every single fence, especially if you're working on super big AAA games, where you may use the resource multiple times in the game. So that's where prefab comes in. Prefab is like a single source of truth, sort of. So basically, all these fences here are just copy of the same fence. This is the original fence, and all the fences you see here are copies of this fence. So if I double click this object, I can see this. But if I, for example, lower this bar to the bottom area, and if I come back to the thing, what do you think will happen? Any guesses?
All of them change.
Yep, all of them change to this super ugly fence. And this is super useful because you can imagine you only need to change once. But of course, another way of changing stuff is, so for example, before I move the stuff, all the fences here are from the same prefab. But as soon as I move something, this also belongs to the same prefab, but it's actually different from the prefab. So you can see, if I select the object here, you're gonna see these things called override. So if I click override and if I click apply all, this will actually apply the changes I made to this specific instance to the original prefab, hence changing all the fences in the scene. So if I click this, it will just all go back to normal. And let me show you again. If I say rotate this bar by this, I'm only changing this instance. But if I come back here and go override and I click apply all, then all the fences will become like this. This actually looks super cool, but yeah. So this is essentially what prefab does. It allows you to have a single file that all other objects can reference to, and you can also change according to the individual needs. And if you think that that change looks good, you can actually apply that to all the different prefabs. And how do you create a prefab? Well, it's actually surprisingly difficult to create a prefab because you have to drag the object to the project. You have to drag the object to the assets files over here. And yeah, you have a prefab. That's it. So if you want to create a prefab, just drag it and drop it here. Then you will have a prefab you can work with. For example, I just make the entire floor a prefab. So if I do something crazy, for example, if I rotate the prefab by a certain percentage, and I come back here, oof, nothing changed. Wait, which happened? Oh, it's probably because I'm changing a local rotation. So the floor might be a bad example. But you can imagine you can have different objects that you can just drag here and change the values here. All right, let's go back to scripting for a second. Will be a good place to do that. Actually, I'm gonna go back to my sample thing. So we have all these cool prefabs we can use, right? But for example, what if I want to say spawn an enemy in the game? Because you can imagine like if you have a shooting game, so you will want to spawn different enemies, right? So you can also imagine like all the enemies are from the same prefab. But how do I spawn that enemy in the script? Well, first of all, we first need to create a prefab. Let's just say our companion here becomes our enemy. We just drag it and drop it here. Now we have a prefab. And you can also notice that once this is a prefab, this thing becomes blue. And then if you click on this, come back here. So I'm gonna create the script. I'm gonna use the method I talked about, which is just click the add component. I'm gonna do spawn prefab. I'm gonna do create new script and create an add. So this will automatically create a new script and also add it to the object. But the downside is that it's not gonna automatically add that to the script folder, so you may have to drag that in manually. Okay, so once we have the script, let's double click, and here we are. So to spawn a prefab, well, we first need a serialized field. And I just noticed I did a bad example because if I'm spawning this prefab, then I probably should not attach the script to this prefab because I'll be spawning myself. Which you can totally do that if you want to. But I'm gonna create an empty one. Let's just call this, say, the game manager. And this will handle all the game logic, you can imagine. And then I'm gonna add the spawn prefab script to this. And this is a prefab I'm gonna spawn. So I'm gonna remove this. So you may notice that this script have this blue line over here. This is actually Unity's ways of telling you that this is different from the prefab we have on file. So if I go to override, and if I click revert all, it's gonna revert all the changes I made to this instance. But if I click apply all, it's actually gonna add a component to the prefab file as well. But in this case, I want to revert everything. So that thing will just go away. And if I come to game manager, and also we have the spawn prefab script. And over here, first I'm going to do a serialized field. So I'm going to expose a variable up there. And I'm actually going to spawn something called game object. And then I would do prefab. So essentially what this is doing is saying I need a variable called prefab, which is of type game object, and I want it to be out here so anyone can edit it. So right now, since we have the file, we have this empty thing over here. So if I go to, this is the cube, this is the prefab we just created. And if I just drag that here and drop it, and there you have it, you successfully have a reference to this object in the script. So right now, if I do, like, for example, if I just like prefab dot position, and if I do something to that, it's actually changing the reference you have. But before you do any of that, the first thing you need to do is actually spawn that thing, right? So I'm gonna put it in start, and I'm gonna do something called the actually I'm gonna do game object, and let's just say cube, and I'm going to call a function. It's called instantiate. This is the most important function. This is the whole point of this demo. So I'm gonna instantiate a game object, and I'm gonna put the prefab here. So as the name suggested, the instantiate function just spawn or create this game object and put that in the scene. Because so far, all game objects only exist in the file in your folder. But through the instantiate function, you actually create that object and make it become an actual instance in the game or in the scene. Now, once we have that, we can just do, for example, cube.position .transform.position, and I can set that to I don't know, new vector 3 0 0 0 to put it at the center. And yeah, I can do stuff like cube.transform say rotation and set to something else. Or I can do like color and set to something else. And I can do like scale, for example, scale. Yeah, scale will be a good one because it's more obvious. And for example, I do like 10, 5, 2. So if I play the game now, I have a cube in the game right now, right? And all right, if I hit play, so yeah, it's a bigger object here. Wait, it's actually so far away from the cube, you can't really see it. Oh yeah, here we go. So this is the object we spawned. As you can see here, it spawned at 0, 0, 0 with a scale 10, 5, 3. And this is exactly what we're doing here. So yeah, that's how you spawn an object in the game, by using instantiate and prefab. And one thing I didn't cover in this lecture is the input system. And that's mainly because, so I'm gonna quickly talk about the old input system. And there's actually a new input system that may be more interesting. But in the old input system, you should just go to game object, and you can go to the where's player setting? I just opened this. So yeah, if you go to project setting in edit, and you should be able to see our input manager over here. So in input manager, you can set different axes. For example, I can say fire 1 responds to mouse 0 left control and stuff like that. Horizontal responds to A and D. And then in the script, for example, over here, instead of creating this object at the start, I want to create it once I press a certain button. If that's the case, then what I need to do is, I first need to input dot get button down. Or even better, I can do get keys. You can get specific keys. Get keys down. And over here, you can do key code ABCD. For example, I can do like key code dot S. That S stands for small. Then I can just put the script I just wrote over here. So again, since update is checking, is calling this whole function every single frame, so you can almost guarantee that when you press the button S, the get keys downs will return the value. And if you did press button S, then this function will be called. So Yeah. Oh, I guess I didn't demo the where is it? So this is using the get keys down function. If I play right now and if I hit S, so nothing is spawning right now, right? But if I hit S right now, you can see the object spawns as soon as I hit S. But right now I'm using get keys down. But another way of doing this is you can actually do, for example, you have a defined fire button or like a defined jump button that responds to different input systems. For example, the controller and like mouse and keys. Like you have the fire button for those. So you actually do get button down, and then you can put the name of the thing you just define. For example, if I do fire one, what is fire one? You might be wondering. You can actually go back here and look at the input manager. So fire one is this thing, fire one, and it responds to the mouse 0, which is the left click, and also left control. So right now, instead of pressing S, if I play the game right now, I need to press the fire button, which is the left mouse. And then once I click it, yep, the object spawns. So that's essentially how the input system works. You can, I can imagine you can do like different stuff like WSAD for movement. And I think it does that for you by default. So you have like jump, horizontal is for A and D, and vertical is for W and S. And you can use this to move your character around in the game. And yeah, I think that's pretty much it for today's lecture. So do you guys have any questions regarding the content I just covered?
Really quick, how do you make the game manager again?
Oh, I just right click and create empty.
Oh, okay, thank you.
So essentially you can actually build, so like you can see there's a lot of different objects here, right? But in reality, you can actually build them by creating an empty game object and adding different components. You can actually build up any object you want by adding different components. Yeah. All right. Any other questions?
Yeah, how do you make the prefab? Is it like you just make an empty object and then just duplicate it over and over again?
Oh no. I'm gonna unpack prefab right now. So unpack prefab just making not a prefab anymore. Make this object not a prefab anymore, but the prefab still exists over here. But let me show you. Yeah, the prefab still exists over here. I'm gonna delete this prefab as well. So if you want to create a prefab, watch very carefully. This is super complicated, so watch very carefully. You need to drag it and drop it. Okay.
All right, I got it. Thank you.
Yeah. So again, so if right now, since I have this prefab, right, and if I want to add more prefab into the game, I can either use that by script, or I can just drag it here like this. And then if I want to change something, I can double click and say I want to change the scale to like 10. And if I come back here, all of these cubes become super long. Yep. Any other questions?
I got one. Back when we were trying to do gravity, I was having a lot of technical issues on my side, so I was kind of lagging behind a bit. But when I tried to type in the code to get the gravity to work, it wouldn't. The object would not fall continuously. It would just do it once and then never again. But I have it in update, so it should be doing that every frame, right?
So we actually did not code the gravity part. Instead, for the gravity, we just add component and rigid body. And once I add that component, if I play the game now, the cube should have gravity now. So you're gonna see the cube falling down.
Ah, I see. My bad.
Yeah. So I think in the update, what we did, so we used that to showcase the on collision enter, which shows like when the object collides with another object, how to detect that. But we're not like manually creating gravity.
Got it. Thank you.
No worries. And you can also mess around with all the settings here. Like if you turn off gravity, then it doesn't have gravity anymore. You can also change different like velocities and angular drag and stuff. All right. Any other questions? So if not, then the exercise for today is actually a bit unique. You're not going to create something. Instead, we want you to defuse a bomb. So we created this thing called the bomb lab. Oh, why is it like that? So if you play the game now, you should be in the bomb lab. And the goal is super simple: defuse the bomb. How to defuse the bomb, you might ask. Well, that's up to you. But there are a few rules though. So yeah, all right, I should read this to you before showing the rules. You have been hired by Obedient Cat, a major AAA studio, to help out with your next hit game, previously mapped for. You sit down to work on your first day when your manager reveals a terrible news. Unfortunately, the notorious Dr. Evil has a vendetta against the company and has engaged in cyber terrorism. Your task today is to defuse the bomb that Dr. Evil has planted in your game. So right now, please open the scene located at the base code at bomb lab and then bombLab.unity. You need to figure out how to defuse the bomb. You'll know the bomb is defused because you will know the bomb is defused when the message says defuse, nice job. And as a starting point, we will recommend you to look at bombLab and bomb.cs, the script bomb.cs. The file contains codes that can make the bomb work. But remember, you can look at the code in bomb.cs, but you cannot edit it. You can move, rotate, or steal any object in the scene. You may edit the Android ID field of the bomb component, which is attached to the bomb game object. So let me show it to you real quick. The bomb game object, you will see an Android ID field. Please edit this. We're going to use that for your attendance. But you may not edit any other field of the bomb game object besides the position, rotation, and scale. And you're probably going to need the Unity event exposed by event onLook and press on button 1 game object. The script is similar to event on trigger script discussed above. And yeah, so we also covered this in class. This is just a tip. So yeah, that's basically it. We gave you a bomb lab, and now go and defuse the bomb. Once you defuse the bomb, please take a screenshot of the word like congratulations, and also show this Android ID when you take the screenshot. All right, any questions? Oh, I can't believe I'm doing a bomb lab twice in a week. Yeah, I think the idea from this bomb lab is actually inspired from the CS class. So yeah. Yeah. All right, if you have any questions, then go ahead and solve the bomb lab. And I'm gonna leave the screen over here so you can check the rules if you're unclear about what you can or cannot edit. And if you need any help, just speak up, like all the instructors are here.